So we have a perfectly qualified team up here to talk about what might be one of the hardest issues or most complex issues that we'll be addressing at FiRe. And I'm glad to have you all here. Thank you for being here. We were joking at breakfast. I said, it's so hard. I think we should just give up and talk about baseball or football or something instead. So instead, we talked about AI. This title, Tunnel Vision, is, of course, not accidental. And it comes partly from, at least my own feeling that it is not well understood by a lot of folks, probably in the audience, in terms of where we really are, what AI really means today, and what are the biggest issues in its limits and in the problem of using it intentionally. So we're going to talk about those things this morning, and each of these folks have their own perspective and histories and levels of experience, and so there is also a fairly obvious story arc that we're going to go through. So I'd like to start with Anand, and who's spent his, I think, entire adult life doing these things. If you could you lay out where you think, can you kind of give a very quick overview of where we are in terms of what AI does and doesn't, and then start the move toward this question of tunnel vision, of like what are the limits of what we're doing?
Yeah. So again, as you all know, AI has been around for quite a long time, right? So arguably since 1956, but the quest for AI has been even before that. The word AI was coined in 1956. So again, the AI has gone through various ups and downs, so what we call as AI winters, and we have always overpromised and underdelivered. And I've been in this industry since '85, and I've seen one of those over-delivery, under-delivery and overpromise. So I think we are probably in the next phase of it. So hopefully there is no another AI winter, but I think there is a lot of hype. So to me, AI, again, classic definition, any system that can sense, think, and act in an environment made up of other humans or machines to achieve a certain purpose is AI. Again, because you've added a purpose, it becomes more narrow AI, and this is the way Russell and Norvig defined it, right? So I just go with that definition. Number of advances in each one of those, so we can go into all of the sensing things that we have seen advances, thinking, mainly machine learning, deep learning, and of course in acting, right? So all of those seen advances. Now, to answer your question around what are some of the tunnel vision that we are getting into in AI, I would say there are three primary things that the AI researchers of today are getting into, that tunnel vision. The first and foremost is that we can do everything with just the data. We don't need a model of the world. If you look at deep learning, that's fundamentally what it is. Feed in all the data, and it is data-rich and model-free. And if you go back 15 years, 20 years, all the semantic approaches and the rule-based approaches, semantic, all were very much, there is a model of the world, right? So we need to have the model because that's how we think, right? So we don't always operate on data. We have a rich model of the world. We were just talking about the medical domain, various domains. So we have a model of the world. That's what we as adults spend maybe 20 years, 30 years studying. And that is key. And we seem to have ignored that at the bulk, right? So there are some very significant advances in the model-based approach, causal models by Julia Pearl, solving some of the counterfactuals and causation issues, which have always been traditionally for the past 100 years, have been issues. So I think we need to take that in board. So that's number one. So try to use the data, but also start looking at the models of the world. And again, I think the previous panel was talking about how complex some of our model systems are, and you need to model those. You just can't work on the data. Why are you essentially constraining yourself with only data when you can accelerate that with a model of the world? So that's number one. Number two, which I don't think is sort of very well recognized, is we are very much in a point-in-time AI solution, not a continuously learning solution. What I mean by that is very few AI is continuously learning. And the ones that learn, the success that you have seen in some of the gaming is because of that continuous learning. Yes, they are using a specific technique of reinforcement learning, and they play billions of iterations to make it very good. So we, for our clients, we have built some of those reinforcement learnings more in the real world as opposed to the gaming world. So this continuous learning, I think, becomes more important, and the industry is just getting into it. So continuous integration, continuous deployment, and now we are looking at continuous learning to attach with it. If you don't have continuous learning, it's something like, just to give an analogy, locking up all four of us, removing all of our past memory, and just giving us enough information about this topic of tunnel vision and foundational issues and say, go and have an intelligent conversation in front of other 100 people. But your memory is completely erased, except for AI foundational issues. How would that feel? How coherent would it be? I see a few smiles, but that's exactly what we are telling our AI to do. There's no context around it. There's nothing that it's learning. There's no model of the universe, model of the world, but we just say, hey, you need to be smart. Let's see how smart you are. Right? So that's the second.
That's number two. Okay.
That's number two. We quickly go to the third. The third, I think, was brought up in the previous discussion. We tend to think of AI as monolithic AI, as if there is one oracle there which knows, understands everything, and is perfect and will give all the answers. Unfortunately, the world is not like that. We are a collection of 7 billion people, I think, as the previous speaker spoke of. So we need AI, which is essentially an ecosystem of AI. So multiple AI talking to each other, collaborating, and competing as well. It's not always collaboration. Competition has its own thing as to bringing out the best in people. So I think it's that also it's needed. Again, there have been systems in the past, multi-agent systems, and I think the previous speaker brought about the GAN, so generative adversarial. That's just two types of systems, but there are literally millions of these things that you can do. So that's the third tunnel vision. I think there's solutions coming for all three, but unless you tackle those, I don't think we are going to get to anything which is sort of general intelligence or even just narrow.
So these are the limits we're facing right now.
Yeah, those are the limits.
Thank you. Well done. We had breakfast, and we were talking earlier, and I mentioned that I had just come from a conference at Department of Energy in Chicago, where they had business AI leaders and national lab leaders talking about problems in AI and working together. And some very large companies were there who spent many billions, tens of billions of dollars on AI. The feeling in the room, and the keynoters from IBM and GE and other places said something that I think would be very surprising to the audience, and that was, we're in big trouble here. We need to change everything. This was not an exultant crowd, right? These are the guys who are the heroes of the universe in AI, in a way, and they were saying, John Kelly from IBM said, we need to make a hard left turn, 90 degrees from whatever we're doing right now, because whatever we're doing right now is run out of runway. And then the person in charge of the same kind of stuff at GE, who they had just fired their entire predicts team not too long ago, talked about how the deep need for change. So obviously they did not have the answers, and I think the people maybe in the audience kind of think like, wow, this is going really fast, it's going great, everything's underway. Not so, and so we'll come back to this. But two of the major issues that are problems, that are tunnel vision problems, that we talked about at breakfast, and there are more, are the lack of explainability. So when Google runs or someone runs deep networks, they can't explain how they got where they got, just where they got. And then what's called the wall, where they get decreasing returns on investment of time or cycles. It gets less and less exciting in terms of the improvements you get as you go along. And then you run out, you're just done. So these are two big problems. So I guess, Andrew, I'd like to kind of have you pick it up there. We understand now what AI means a little bit, but the tunnel part, let's go into that.
Yeah, I mean, to pick up a little bit where you were talking about on the model-driven side, right? So we've spent the last 15 years being very fascinated by machine learning for good reason. It's made tremendous strides. It's being applied very effectively in a wide range of problems. But now the tools are fairly mature, and we continue, because they've been so effective, one of the tunnel vision aspects that we have is we construe everything as a classification problem. And if we can't construe it as a classification problem with a ton of data and training examples, then somehow it doesn't count. It's not something that we want to attack. And in practice, okay, fine, we have this one tool, but that's a small part of the broader range of problems we want to attack. So while we're all worried about the singularity and everybody becoming unemployed, there are some gaping holes in our capability. So for example, you're holding that cup. Is that cup garbage?
That cup's recyclable.
Okay, so there isn't a system on the planet today that could answer that question, if that cup is garbage, right? This kind of common sense reasoning that we all take for granted. I'll give you one of my favorite examples. If I ask you, what's better to carry water with, a shoe or a sock? Okay. Anyone having trouble with that question? Right. Okay, so a 5-year-old can answer that question. Again, there isn't a system on the planet that can answer that question. And the 5-year-old can answer it not because they've seen 10,000 examples of people carrying water with a shoe or 10,000 people trying to do it with a sock. They can do it because of some basic common sense reasoning. Right? And that continues to be a very important gap for us that is barely considered when we think about machine learning or AI because we're so focused on applying AI. And so people like Jeff Hinton, for example, do point to that as a gap and a direction that they want to, for example, when we talk about making a right turn, that's an important area. Now, from the business side, one of the important questions is, all right, how much money do you make being able to distinguish between a shoe or a sock and carrying water? Why is that an important question? Well, thinking about the kind of common sense that would make sense for business problems, for applied problems, is interesting. We're decades away, I would argue, at a minimum, from having systems that could arbitrarily answer questions like the shoe and sock problem. But what would it mean to imbue limited forms of common sense into the kind of applications we have? So let me give you an example. If we have, and when we talk about the division of labor, let's say, between people and humans, one of the ways I like to think about it is people are very good at thinking deeply about a small number of things. Computers are really good at thinking shallowly about a very large number of things. And so if we have, let's say, a system, one of the things that we worry about is monitoring vendors to help our clients with supply chains. Right? Is there some risk? If you have 10,000 vendors, how do you identify risks associated with a particular vendor? So now today I read, or a system reads about a rubber strike. So who should be which of our clients should be notified about this? Right? Which of the potential vendors are at stake here? Right? So, okay, probably doesn't make much sense to worry about it from, let's say, an entertainment company or a hotel company, but maybe the car companies that rely on tire vendors for which rubber is an input. That's the kind of thing where those are the kind of inferences, a kind of business common sense inference that you might want to worry about. This style of thinking, this kind of inference, of call it business common sense reasoning, is a huge gap and is the kind of thing that we're starting to turn our attention to. Because in practice, when it comes to solving the problems, having the tools is great, but being able to reconceive of the problems, to rethink what the key concepts are, to focus on the knowledge representation, for us, that's a key gap that we're trying to attack.
Right. So you mentioned something which I also think the audience may not know, and therefore I would like to emphasize it. When you said, we're looking at classifiers, right? We're looking. So I'd like to point out something which I think will surprise all of you. So at this DOE meeting last week, which I told you guys about, I was on a panel, and I said, I'm going to stick my neck out here and suggest that there were 400 people in this meeting, that all of you who are in AI, of all of you, 95% or so are working with one tool called neural networks. True or false? And it was true. So all of us who are talking about AI right now, we're not talking about AI. That's the superset. We're talking about neural networks. And so, when Andrew says that, what he's really saying is the failure of neural networks to be able to go beyond classifying things is a really big problem. So I would like to just kind of move us along and suggest that right from the get-go, before we even start talking about the details of the world and how it works or how we're interfacing math with the world, we're only using one monkey wrench at the moment, or most of us are. And that has very easy to discuss failures and limits and constraints built into it. So Paul, your job is to make all this stuff actually, well, everyone's job, but perhaps most of all on stage, to make this really work day to day with real life companies. So what do you see in terms of these limits and the tunnel vision, and how do they keep people from getting where they got to go?
Right. So I'll pick up on a few things, and I thank you. I ran a panel yesterday as well, so on AI. So it was great to get everyone's insight. So I'll kind of join some of the dots. So I think there is a misconception about what AI is. Anand talked about it earlier on. We kind of gravitate to certain things. So autonomous driving, or we talk about healthcare. So number one, again, going back to the definition, is it's the ability for machines to sort of do human-like things and have sentiment, make assertions, and so on. So I think it's important to understand what AI is, and I think we of course gravitate to kind of certain scenarios, and then also across industries. So of course there's some fantastic stuff going on around healthcare, and especially thinking about genomics and kind of breaking the genome code. But AI is prevalent and happening across all industries, from banking to manufacturing to even insurance, as an example. So I think it's important to get that sort of fundamentals in place, and so build that understanding. And then the sort of the second piece, before I get to sort of Mark's question as well, is just I think there's a PR problem around AI, and I get the concerns about kind of AI, and I think there's been lots of movies and so on that are driven sort of perceptions and this confusion between AI and even robotics and joining the two, and Rage of the Machines, and lots of people kind of talk about that. I think there is absolutely governance required and legitimate concerns around AI and making sure that it's used for good and not for bad. But let's be clear. I mean, AI is being used prevalently in industry today. There you get a lot of PR and publicity around sort of the big breakthroughs, but even just fundamental things, helping the daily lives. So I work with a lot of partners building solutions using AI across the world in all industries. And I also work with lots and lots of startups who are driving some of this new innovation. So bringing back to your point, Mark, I mean, I think as one of the vendors of many that are trying to drive innovation around AI, I think there's a few things to think about. I mean, so again, AI is not new. You mentioned kind of go back to kind of the 50s and the 60s. I think some of the things that have changed that have allowed the innovation to happen is first of all, cloud computing. So making computing power and capabilities a commodity and at a price point that's accessible to the mass market. That's a good thing, because it's not then an elitist technology. It can be used. Mass market means that you can get more people, more innovation, more insights. So I think that's a big thing. Mark talked about deep neural networks. You can go read the book from the 60s. Anyone who's done their PhD in AI and neural networks will kind of talk to you. But the advancements, the second kind of big advancements is around the algorithms, and that still needs to continue to innovate. So there's kind of, we talk about the pace of innovation, but we talked about the shallowness of the pace of innovation. I absolutely agree. There's innovation, but potentially in superficial areas, that there isn't that sort of deep innovation. And so there needs to be continued innovation in the algorithms, in the computing power. I mean, I'll talk about, just for out there, sort of things like quantum computing. Think about, sort of the evolution just even the last 5 years of how expensive it was to actually go buy a machine that had GPUs. I think there was a stat from FiRe Computing or Best Buy, one of the two, that says one of their biggest selling things because of Bitcoin was machines with GPUs, right? But that price point has now come down, and it's also a SKU that you can go use in cloud computing. So to Mark's point, I mean, I think I daily see the innovation happening across AI, and I would just land some simple scenarios to show that innovation. So I get involved, for example, with Microsoft, something called the Imagine Cup. So I work with students a lot. And so one of the winners from that competition that I was on the judge panel of was someone that built a solution using artificial intelligence for blind and hard to sight people. So using things like image recognition from your phone, or using kind of goggles and so on and so forth. That's you think about AI for good. Or if you think about insurance, which was my previous well to Microsoft, think about how many of you actually have life insurance policies. Well, at the end of the day, you want to make sure they pay out right. So there's this thing called financial modeling that is making predictions on things like mortality and solvency and so on, that artificial intelligence is playing a big role there. And to run those predictions is huge, right? So you need to use things like artificial intelligence to do things like stochastic modeling that can be done in real time and learn from that. Or things like experience studies in insurance that says, what do the mortality tables look like? So thinking about predictions about single white female in this population, in this line of business, what does that look like? Or look at things like manufacturing and logistics, being able to look at things like supply chain. So how do you innovate in supply chain? So natural disasters occur. Well, how do you use artificial intelligence to go get those weather reports or those crises reports and push that into the supply chain and reroute the logistics, whether it be kind of the ships or the tankers and so on and so forth. Or manufacturing. In manufacturing in the US today, pretty much in the small to medium business, there's 50 or less people in manufacturing within manufacturing companies in the US today. So think about innovation around AI for small factories and driving innovation. And there's a huge problem in manufacturing around the de-skilled worker. So using artificial intelligence to help on things like predictive maintenance. So it's very costly to have downtime. It's even more costly if a machine actually goes the wrong way and blows up. And so using artificial intelligence to do some of that predictive maintenance is critical. And of course, we've talked a lot about healthcare, but my point is that to pull it all together, there's sort of the high-end problems that innovation continues to need to happen. But there are just kind of problems being solved in everyday life that are super important. If you think about those industries, being able to drive that new intelligence, those insights, that's happening today. I'm working with all those companies on a daily basis. They're not necessarily the cracking the genocode, the high-end problems, but the capabilities of AI is at the right level. So hopefully you see that we need to continue to innovate. Hopefully you see that there is AI for good, as well as the very legitimate concerns about AI for bad. And kind of in closing, I think me doing this sort of pitch and raising awareness, the thing that's going to drive that further innovation is everyone in this room, in terms of the real use cases, and then obviously partnering with companies like kind of Microsoft and others and so on and so forth in terms of the platforms. But it's not a one person solves all. It's the collective coming together. But I think it's super important to be focused. Fragmentation across lots and lots of problems is not going to have people focused. So I think solving a smaller number of real world problems that are going to have impact, and having the smart people doubling down on that and the innovation around that, I think is going to make what the true impact for AI.
Thank you. So I think what you've seen from all three of these gentlemen is a fascinating story of where we are and of the extreme limits just around where we are. And while I think the general public is probably exposed more to the Paul side of the world, where they're thinking, wow, every toothbrush is going to have AI, and it's all, the whole IoT thing, and it's just will never end. This is a beautiful universe blossoming before us, and that's true. But at the same time, the people who are doing deep research on these things are pulling their hair out because the tools are not powerful enough yet. And one way of thinking of this is so how I think about it is pick any problem you want. Whether it's you want to play the market, or you want to solve a medical problem, or you want to understand how a leaf works. These are very, very, very complicated systems, and we're using tools which will, at best, generally work on one or two things at the same time. So that won't work. That's a guaranteed fail. So we're at the baby early steps of this, applying mathematics to the world against the world's problems, and we're looking at onesies and twosies, and we know that the solutions are going to come in thousands or hundreds or millions.
So yeah, exactly as what you said. I think if we make the distinction, I think what Paul was talking about is AI as an engineering discipline, versus AI as a science.
Yeah.
As an engineering
Right.
discipline, there's lots to be had,
Yes,
right? So
yeah.
great ROI, so we should all go ahead. But at the same time, let's not fool ourselves in saying that the science is solved. Science is not solved. So AI as a science still has to go through. And this might be a 20, 30-year journey.
Yeah.
And I take inspiration from the whole genomics and that area. Even before DNA was discussed or even identified, people were working with plans to get better species, right? So with no understanding of DNA. Once the DNA came, there was another 30 years, 40 years before we can go into the genome.
That's
and
right.
the human genome was mapped. When everyone said the problem is solved, it's not,
That's
right?
right, yeah.
So we still have the problem. So
Yeah.
we're still working on it. But it's far better now with CRISPR-Cas9 than what Mendel was doing.
There's
right?
the
So that
hopeful
is-
note right there. Okay.
That's the sort of the spectrum that we are.
You're right.
Can I put my pitch in, Mark? Is
Wait,
that-
before, I
oh,
think
yeah,
we got two guys, and
Oh,
we got 104 left. So, and this guy actually is an amazing expert. So, Ty Carlson from Pattern Computer.
Yeah, Ty Carlson from Pattern Computer. The one thing I want to push back on somewhat firmly, because I keep hearing AI, and every time I hear AI, one of the arguments I had within Amazon when we developed Alexa was that AI really needs to understand context. I mean, to the sock example to some extent, but without understanding context, it really is just machine learning. It's just applied machine learning. So it's not AI. So I want to be kind of clear about where our limitations are in doing that. So we're really talking about machine learning, we're talking about neural nets, and that's great. And they're very, very powerful and they're very capable. And we see different variations of neural nets being applied. But what excites me most is about the left turn, is because there are companies that are actually doing things different, that are, instead of doing pattern recognition, for example, are doing pattern discovery and things like that that are outside of the normal realm, that actually change the rules. And that's, to me, the exciting part of what machine learning has led to, is new design of new algorithms that are fundamentally more scalable, more flexible, require less compute power, and yet come up with some powerful solutions. So I'm excited by that, but I challenge the definition of AI of understanding context, because if you understand context, the implications, where are you at, what environment you're in, because with Alexa you can say, you can ask for this and it figures out what domain you're in and now what slots are, right? So and that's just very basic, if this, then that kind of knowledge things. It has some magic to it, but it's still just machine learning. So we have a ways to go to get to AI. I'm excited about the future.
Yeah, I'm not sure when you say that you're pushing back on the need. Are you saying we don't need context, or?
No, we desperately need
Oh, yeah,
context
okay.
to say intelligence, right? Intelligence, machine learning, it's really machine learning. If this, and we have a bunch of layers, and it comes out, and we have the following. Now, we can figure out what's in those layers. But it's still just a learning experience. It's not the intelligence, because intelligence means implications and subtleties and context. And that's what we're missing about the richness, to me, to say AI. Even if you're avoiding hitting a car, it's just an algorithm saying, that's a person, I need to avoid it.
Okay, well, let's put some of the definitional questions. I mean, if we look at the term AI, what does it mean? Go back to John McCarthy, who coined the term in the 50s, and what they were talking about at the time was, well, human cognition should be able to be modeled precisely enough that you can create a model of it on a computer and run it. Right? So that definitionally, that's how it started.
That's
Now,
an old definition. Yes.
What's that?
That's an old definition.
Sure, but that's
That's a
why.
classic definition, right? So
Yeah.
the question is, do we want to redefine AI as being, look at all the proceedings, right, from 56, machine learning was always part of AI,
Yeah.
right? So if you want to say, and that's the bane of AI, anything that is not discovered is called AI. Anything which becomes a concrete thing is no longer called AI. And of course, we have seen the machine
That's
learning.
just X.
Yes,
as soon as you
right.
understand
Or
it,
it's
that's
just
X.
or it's just pattern
Yeah.
recognition. It's
Right.
just voice recognition because we all have it on Siri,
Yeah,
right?
like-
So, but to me, that's all AI, right? So we have solved those things. So let's move
The
on
challenge
to
is the
unsolved.
context. The challenge is the context. Thank
Yeah.
you.
It's
Well,
still a problem, yeah, which is still a problem.
But I
yeah.
strongly agree with you on the context. And one of the fights or implicit fights within AI over the last 30 years has been the statistical approach versus a knowledge-based approach, right? And both extremes, in my view, are wrong. Right? So roughly speaking, the extreme semantic side of the world said, I'm going to go into a room and I'm going to represent the world, and I'll see you in 30 years when I have this perfect model. Right? And the statistics side of the world said, yeah, good luck with that. We have a ton of data. Why bother representing anything when I can just throw my hardware at all this data and come out with these beautiful systems? And by the way, you're biased and you don't actually know what you think you know. Right? So those were the two extremes. Now, and by the way, the current
Andrew, I
version.
think we have to wrap this up.
Okay.
Thank you, everybody. We did go over time. Thanks, Ty, for asking that question.
Thank you.